Hey, good morning again. It's John. I wanted to work with LTspice and the ink saver side by side with each other because there are some new keys or hotkeys that you can use with the new LTspice version by ADI, LTspice 24.1, and I'm going to do a simple voltage source and resistor divider circuit. In this one, that meaning there's going to be two resistors. So let's have a voltage source here. Press V, V1. That's voltage source 1. You can see that it's about to create V2 and V3 if I click. I'm going to press the escape key. Let's see. Next is going to be resistor 1. Over here, and resistor 2 over here. And then we're going to have a ground. Press G for ground. And then the wire is going to be function F3. So the wire, I was messing up with this earlier on the previous live stream, so I ended that live stream, and now we're wiring this up over here. I'm getting a phone call right now. Let's see if I could okay, and then wire up here and wire down here, so that it's a closed circuit. We need a closed loop. Okay? And then right click here, so then I'm going to press option, right click, or command click, or control click actually, or double click. Nope. Which is it? Function? Option. Right click. I'm trying to right click. Control. There we go. View, edit, move, draft, draw, hierarchy. No. Function. Option. Option. Should be what? Right click. No analysis. I'm going to use my regular mouse. Let's see if I can use my regular mouse. Okay, so then we're going to right click here. There we go. Okay, DC value. Let's say it's a 12 volts for a car battery. 12 volts for a car battery. And then we're going to use 10, instead of 10 ohms, we're going to do 10K, which is 10,000 ohms. And over here, 10,000, 10K. Remember, m, lowercase m is for milli, so that's 10 to the minus 3. Lowercase k is 10 kilo ohms, which is 10 to the positive 3. Okay. All right. And then we can name this net over here. I'm going to do a function F4. Let's just call this VA, V sub A. And then I'll write a note here. If I can write an S comment, what is the voltage at VA? I'm going to write a comment here. What is the voltage at VA? So then I'm actually going to take my iPad over here, and we're going to go to a screen mirroring. Okay. And then so we had a 12 volt source here. just going to do some hand calculations. 10k ohms, 10 kilo ohms, and then this is VA over here, VA. What is VA? So then VA is going to be, this is R2, this is R1, it's going to be, this is V source, VA is going to be equal to V source times R2 over R1 plus R2. I think that's correct. Let me see if the calculation is correct. So VA R2 is going to be 10k over 20k. So VA is equal to 12 volts times R2, 10k ohms, divided by 10k plus 10k, 10 kilo ohms plus 10 kilo ohms. So 10 over 10 plus 10 is just 1/2. VA is equal to 12 volts times 1/2. VA is equal to 6 volts, which is not just mathematically correct, but if you just take a visual inspection, test by inspection, the voltage is going to lose half of its voltage with the drop in the 10k resistor. And since there's two 10k resistors, right in the middle is going to be half of the value of the source voltage. Okay, so I'm going to stop screen mirroring, stop mirroring, and then we're going to actually do a simulation here. S for spice directive. I'm going to do .op for DC operating point, and we're going to test if the simulation has the same answer as our hand calculation on the iPad, and then we're going to run, and then I'm going to probe the voltage here. Oops, where'd it go? We're going to add trace, so V1 and VA. How do I express V1? Just V. What about that? V1 like this. How do I like this? Oh, okay, V1 and then VA. And then if we check on the screen, I guess the .dc operating point on Mac is different from Windows, because with Windows it gives you a text file. However, since we're working with Mac, it gives us V1 over here, or I1 V1 over here. This should not be I1, it should be V of V1. Okay, let's delete that. And then, here it says 6 volts right here. I'm going to change the color so then you can see it, How do I change the color? Right click. Okay, 6 volts. There we go.